Test algebraically to determine whether or not the graph has symmetry about the x-axis, the y-axis, or the origin. To determine whether or not the graph has symmetry about the y-axis, we're going to replace each x value in the equation with negative x. So we begin by opening up holes for those x variables, but we're not going to do anything to change the y variables in this step. So we replace the x with negative x, and then we simplify to determine whether or not we're going to get the same collection of ordered pair solutions. Essentially, when we replace x with negative x, we're flipping the graph over the y-axis, which means that these points are going over to the other side. And when that happens, is the result going to look like the same graph as the original? In other words, algebraically, are we going to have the same collection of ordered pair solutions? So when we square negative x, this becomes positive because the negative is also being squared. And then we have plus 3y squared is equal to 9. And when we compare that back to the original, we see that, yeah, that's the exact equation that we started with. So this is going to give us the same collection of ordered pair solutions. And therefore, we are going to have symmetry about the y-axis. In order to determine whether or not we have symmetry about the x-axis, we're going to replace y's with negative y's in the original equation. So in this step, we're not going to change the x's, but we're going to open up variable holes for the y's and plug negative y's in. When we replace y values with negative y values, we're essentially flipping it over the x-axis to make those y's opposite in sign. And when we do that, do we end up with the same graph? Is the graph symmetrical over the x-axis? So we're testing this algebraically by plugging negative y into the equation and then simplifying that equation to see if we get the same collection of ordered pair solutions. And since when we square a negative, it gives us a positive quantity, we end up with exactly the same graph that we started with. So again, yes, we do have symmetry about the x-axis. Now we're going to determine whether or not we have symmetry about the origin, and in order to do that, we're not only going to plug in negative x for all the x's, but we're also going to plug in negative y for all the y's. So negative x goes in, and negative y goes in, and now we simplify to see if we get the same collection of ordered pair solutions, and again we get the exact same equation, no change on either side, and so for this example we have symmetry everywhere. We have symmetry about the x-axis, the y-axis, and the origin.